Hello, everyone. Welcome to SleepSpace. Tonight, we will talk about what might happen if parallel universes were to collide. This is a question that takes us beyond ordinary science into a realm of imagination, where physics, philosophy, and even the limits of human understanding meet. To explore this idea, we'll start with the foundation: what parallel universes are thought to be, how scientists imagine them, and why their possible collision is such a fascinating and sometimes terrifying concept. When we hear the words parallel universe, it can sound like something out of science fiction. Yet physicists have long considered the idea, not because it makes for good storytelling, but because the mathematics of modern theories sometimes suggest that universes beyond our own might be possible. In fact, there are multiple interpretations of what such universes might be like. Some stem from the theory of quantum mechanics, where every possible outcome of a situation might give rise to a new branch of reality. Others come from cosmology, where the very process that inflated our universe into existence might have created countless other bubble-like universes as well. At first glance, these universes are imagined as being separate, like soap bubbles floating in a vast invisible foam, never touching, never crossing paths. But if we dare to ask, what if one did touch another? What if these separate realities were not as sealed off as we think? Suddenly, we step into a thought experiment that shakes the foundations of our assumptions about reality itself. To get a clearer picture, it helps to imagine our own universe as a fabric. This fabric is space-time, the stage on which everything unfolds. Galaxies spin, stars ignite, planets orbit, and life evolves. Now imagine another fabric lying just beside ours. Most of the time, there would be no way to cross from one to the other. The rules that govern one would be neatly contained within its own framework. But if those fabrics brushed against each other, the result might be unimaginable. Would the two universes merge into one? Would their physical laws mix and interact? Would reality itself tear apart under the strain? Scientists who toy with such ideas sometimes use the language of collisions because it gives us an image we can grasp. Think of two galaxies colliding in the depths of space. At first, they remain distinct, their stars whirling past each other with vast stretches of emptiness in between. Over millions of years, their gravity reshapes them, tugging on stars and gas clouds until eventually a new, merged galaxy forms. If universes collided, might something similar happen on a cosmic scale, except instead of stars and planets, it would be the very building blocks of physics, like particles, forces, and dimensions, reshaping into something new. The first step to exploring such a scenario is asking, are parallel universes real in any sense we can use that word? While we have no evidence that other universes exist, many theories allow them. For instance, string theory, which attempts to unify the known forces of nature, suggests there may be extra dimensions curled up beyond our perception, and within this framework, other entire universes might emerge. Inflationary cosmology, a theory describing how the universe expanded in the first moments after the Big Bang, suggests that what we see as our universe might be just one bubble in a vast sea of bubble universes. Some cosmologists call this the multiverse. The multiverse is not just one idea, though. It comes in many flavors. Some describe infinite copies of our own universe spread out in space so far away that we could never reach them. Others describe branching realities, where every choice, every quantum event, gives rise to another path of history. In that interpretation, there might be countless versions of you, each living out different possibilities. One who became a musician, another who chose a different city to live in, another who never existed at all. The thought of those universes colliding is unsettling because it suggests that these sealed-off realities are not so sealed after all. If they can interact, then we must wonder what keeps ours stable. Could a collision rewrite the past? Could it alter the laws of physics midstream? Would we even notice it, or would it happen in an instant so overwhelming that there would be no time to realize what was occurring? To understand this more deeply, let's use an analogy. Imagine two sheets of paper floating side by side. Each sheet has words printed on it, telling a story. On one sheet is our universe, with its galaxies and stars and human civilizations. On the other sheet is another universe, perhaps with different laws, different structures, perhaps even no life at all. If those sheets were to overlap, the words would blur together, creating a story that made no sense, or perhaps a new story entirely. But unlike paper, universes are not flat objects. They are dynamic, filled with energy and governed by rules. If two universes were to collide, it could unleash energies far beyond anything we know. Some cosmologists even suggest that the birth of our universe might have been caused by such an event. Perhaps the Big Bang itself was the collision of two higher dimensional realities, releasing a flood of energy that expanded into the cosmos we inhabit. If that's true, then a universe collision is not just a fantasy, but potentially part of our own origin story. The consequences of such a collision are difficult to pin down, because it depends on how similar or different the universes are. If they share the same fundamental constants, like the speed of light, the strength of gravity, or the behavior of atoms, then their merging might be less violent. The universes could weave together, forming a hybrid cosmos with a strange mixture of features. If, on the other hand, their rules are vastly different, the collision might be catastrophic, obliterating the delicate balance that allows matter, chemistry, and life to exist. Let's consider the scenario where the physical laws are similar. In this case, the collision could look like a massive energy surge. The very structure of space-time might ripple like a pond struck by a stone, creating distortions that spread across galaxies. Observers might see unusual effects, stars appearing to bend or vanish, strange cosmic phenomena that defy explanation. Eventually, the two universes could settle into a new equilibrium, where their combined matter and energy form a larger universe with new possibilities. Life might adapt, evolve, or even thrive in ways we cannot imagine. Now imagine the opposite. Universes with incompatible rules. Suppose one universe operates with 3 dimensions of space and one of time, as ours does, while another has a different number of dimensions altogether. Their meeting might shred the fabric of both, leaving only chaos behind. The particles that make up matter might no longer be stable, atoms might unravel, and the entire concept of space and time might dissolve. From our perspective, it would be the end of everything familiar. Some thinkers even suggest that we might have subtle evidence of such events in the cosmic background radiation, the faint afterglow of the Big Bang. There are hints, though highly debated, that patterns in this radiation could be scars left by collisions with other universes long ago. If true, then our universe may already bear the fingerprints of such encounters, though we may not yet understand them clearly. At a philosophical level, the idea of colliding universes forces us to confront questions about identity and continuity. If our universe were to merge with another, would we still be who we are? Or would our very sense of self dissolve into something unrecognizable? Would history itself be rewritten, with every memory altered to fit a new reality? Or would we suddenly be aware of 2 conflicting versions of existence at once, like overlapping dreams? The unsettling beauty of this thought is that it pushes us to see our reality not as fixed, but as part of a grander, more fluid picture. We like to think of the universe as stable, something we can rely on. Yet physics hints that at its deepest levels, reality is not as rigid as it seems. Atoms blink in and out of existence. Particles exist in multiple states at once. Space-time curves and flexes under the weight of gravity. If the very foundation of our reality is flexible, why not the boundaries of universes themselves? For now, these questions remain beyond the reach of experiment. We can build models, we can imagine scenarios, but we cannot force universes to collide in a laboratory. The scales involved are unimaginably vast, and yet the act of imagining opens new doors. By asking what would happen if universes collide, we push our thinking into realms where physics, philosophy, and storytelling meet. It's in this borderland that human curiosity thrives, where our wonder about existence reaches its sharpest edge. As we continue deeper into this exploration, we'll look at possible consequences in more detail. Could new forms of matter arise? Could entirely new kinds of life emerge from such an event? What clues might we already have that collisions are possible? And most intriguingly, what does this mean for our place in the cosmos? Knowing that our universe may not be the only stage on which reality unfolds. The behavior of our reality comes down to a handful of fundamental constants and laws. These include the speed of light, the strength of gravity, the mass of the electron, and other delicate balances. If any of these values were even slightly different, the universe as we know it would not be the same. Stars might never ignite, atoms might not hold together, or chemistry might not exist in a stable form. So when imagining another universe, we must consider whether those constants would match ours or not. This is crucial because a collision between universes with identical constants might be less catastrophic than one where they differ. If they align closely, the merging could be like pouring water into water, disturbing but ultimately blending into a continuous whole. If they differ radically, it would be more like mixing water with fire, destructive, volatile, and unable to coexist peacefully. One possibility scientists sometimes consider is that universes could exist in higher dimensions, beyond the four we are used to. In certain versions of string theory, our universe might be like a membrane, called a brain, floating in a higher dimensional space. If that's the case, then a collision might not just be a possibility, but an inevitability. Brains could drift through the higher dimensional space, and eventually, they might crash together. Some theorists even propose that the Big Bang itself was triggered by such a collision between brains, releasing an immense burst of energy that expanded into our universe. If that's true, then our entire reality is already the result of a collision, and the idea of another one happening is simply part of a larger cosmic cycle. Imagine for a moment what this would mean. If universes collide regularly in higher dimensions, then creation and destruction might be ongoing processes. Our universe might not be unique, but simply one of many temporary stages that rise and fall through endless cycles of collisions. This reshapes how we think of time and permanence. Instead of a single beginning and a distant end, the cosmos might be built on recurring events, each birthing new realities. But what would the direct experience of such a collision be like for us, as beings living inside a universe? The answer depends on scale. If universes are truly vast and separate, their merging might unfold over billions of years, too slow for any single observer to notice. It would be like watching continents drift on Earth. The change is real, but imperceptible in a human lifetime. On the other hand, if the collision occurred in a way that was abrupt, it could transform reality instantly. Space-time could ripple, the laws of physics could shift, and everything we know might be altered in a heartbeat. One of the strangest possibilities is that we might not even realize it. If universes collided in such a way that the merging rewrote the conditions of existence smoothly, then our memories, histories, and perceptions might shift along with it. From our point of view, nothing would seem unusual because we would have no baseline for comparison. We might already be living in a universe that has merged with others in the past, carrying scars or imprints of those encounters that we cannot consciously detect. Some scientists have searched for evidence of this idea in the cosmic microwave background, the afterglow of the Big Bang that still fills space. Certain irregularities in that radiation, some suggest, could be traces of past collisions with other universes. Circular patterns, unexplained cold spots, or asymmetries might hint at an event where another universe brushed against ours. While none of this is proven, the very fact that researchers look for such patterns shows how seriously the idea is considered in some corners of cosmology. If a collision did occur, another question arises. What would happen to matter itself? The atoms in our bodies, the stars in the sky, the galaxies spread across billions of light years. All of them are built from particles that follow specific rules. If another universe with different rules collided with ours, would our particles remain stable? Perhaps they would suddenly behave differently, reshaping into new structures. Chemistry as we know it might vanish, replaced by strange new forms of matter we cannot currently imagine. Consider water, one of the most familiar substances. In our universe, it is essential to life, shaped by the way hydrogen and oxygen atoms bond. If the laws governing those bonds changed even slightly, water might not exist in its current form. It might be unstable, or it might not form at all. Now imagine that happening not just to water, but to every substance in existence. The collision of universes could be like rewriting the recipe of reality, changing every ingredient and interaction in ways both subtle and profound. Another angle to explore is the idea of dimensional shifts. If universes collide and one of them has more or fewer dimensions than ours, the outcome could be extraordinary. For instance, what if we suddenly gained access to a fifth spatial dimension? Our perception of reality would be transformed. Objects might appear to change shape or location in ways that defy our understanding. Distance and direction could lose their meaning. We might experience existence not as a three-dimensional environment, but as something vastly more complex. This opens the door to speculation about consciousness. Could a collision of universes alter the very structure of awareness? If our brains are products of physical laws, then changing those laws could alter thought itself. Perhaps in a merged universe, we would think in ways unimaginable today, seeing time differently, understanding connections instantly, or perceiving multiple realities at once. Consciousness might expand, dissolve, or evolve into a form that feels alien compared to our current experience. Of course, we must also consider the destructive side. If universes with incompatible laws collide, the most likely outcome may be annihilation. Spacetime itself could unravel. Particles could disintegrate. The delicate balance that holds the cosmos together could fail, leaving only a void. In that sense, a collision could be not just transformative, but terminal. Our universe might vanish without trace, absorbed or obliterated by the other. Yet destruction is not the only possibility. In some models, collisions create entirely new universes. Just as the impact of two stars can scatter material that eventually coalesces into new stars and planets, so too might colliding universes seed the birth of new realities. In that scenario, our universe might continue in some form, while also giving rise to offspring universes branching off into higher dimensions. Existence, then, would not end but proliferate. These ideas blur the line between physics and philosophy. They force us to ask what it means for something to exist, and what role our perspective plays in defining it. If universes can collide, merge, or give rise to others, then existence itself is not fixed. It is dynamic, fluid, and endlessly generative. We, as conscious beings, are simply one small thread in this vast, ever-changing tapestry. The thought experiment becomes even more striking when we consider personal identity. If universes merge, do we continue as the same individuals, or do we become something new? If history itself is rewritten, then who we are might also be rewritten. The version of you listening to this right now might dissolve into another version with a slightly different past, different choices, and different outcomes. In that sense, a collision could erase individuality as we know it, while also creating infinite variations of it. At the heart of all this lies a paradox. Colliding universes could be the most catastrophic event imaginable, yet also the most creative. They could destroy everything we know while also giving birth to realities we cannot yet dream of. The very act of contemplating this duality stretches our minds, reminding us that the universe, whether singular or plural, is far stranger than our everyday experiences suggest. On a smaller scale, the universe is filled with examples of immense structures meeting and transforming one another. Galaxies, for instance, collide regularly. When this happens, their stars mostly pass each other without direct contact, because space is vast and stars are relatively small. Yet gravity reshapes the galaxies, pulling them into new forms, igniting waves of star birth and scattering gas and dust across interstellar distances. From a distance, these collisions look almost elegant, like cosmic dances unfolding over millions of years. If galaxies can collide, and if universes themselves are vastly larger structures, perhaps we can use galactic encounters as a metaphor. The key idea is that not every collision is purely destructive. Collisions can also be creative. They can tear apart old forms while giving rise to new ones. That duality may hold for universes as well. A merging of cosmic fabrics could erase some aspects of reality while also inventing others that never existed before. Yet universes are not made of stars and gas alone. They are made of laws, and laws cannot simply overlap without consequence. Imagine two legal systems, each governing a nation with different rules. If the nations were suddenly forced into one, conflicts would erupt, laws would contradict, practices would clash, and citizens would struggle to adapt. Similarly, if universes collided, their laws of physics might not agree. One might allow electrons to orbit protons at a certain distance, forming stable atoms, while another might require entirely different interactions. When those universes merge, the result could be unstable. Matter as we know it might dissolve. Still, it's possible that universes with similar laws could interact more harmoniously. If the constants matched closely, the transition might not be catastrophic. Instead, it could look like a ripple across the cosmos. Light might bend in unusual ways. Time might feel distorted. The structure of space could ripple with gravitational waves far stronger than anything detected so far. For beings within such a universe, the event might feel like a strange cosmic storm, unsettling, incomprehensible, but survivable. One fascinating aspect of this thought experiment is the possibility of overlapping histories. Imagine two universes where the same basic events have occurred, but with small variations. In one universe, a civilization might have flourished where, in ours, it did not. If those universes collided, would those histories blend? Could we suddenly inherit the cultural memory of another world, as though our minds were flooded with stories and knowledge from beyond? The idea is speculative, but it highlights how deeply a collision could affect not just matter, but meaning itself. This leads us to consider information. In physics, information is not just knowledge, it is a fundamental component of reality. Some physicists argue that information can never truly be destroyed, even when black holes consume matter. If universes collided, then what would happen to their information? Would the data encoded in every particle, every interaction, every past event merge with ours? If so, reality could become layered, a tapestry of overlapping truths. To grasp this, think of language. Imagine two different languages suddenly merging into one. At first, communication would be chaotic. Words would overlap, meanings would blur. But over time, a new hybrid language could emerge, combining aspects of both. If universes collided, their information might undergo a similar process. The result could be a reality with blended laws, where the old rules persist in altered form, while new patterns emerge alongside them. From another angle, we can ask whether life could survive such an event. If the collision were destructive at the atomic level, life as we know it might end instantly. But if the event were less severe, if it altered conditions gradually, then life might adapt. Evolution has always been shaped by dramatic changes, from asteroid impacts to shifts in climate. A universe collision might be the ultimate environmental change, forcing life to evolve in unprecedented directions. Perhaps consciousness itself would stretch to accommodate new dimensions, perceiving layers of existence that were once invisible. Some thinkers speculate that such an event could even explain mysteries in human experience. For instance, sudden insights, strange visions, or unexplained phenomena might, in this speculative frame, be fleeting moments where our universe brushes against another. If universes overlap briefly, perhaps fragments of other realities bleed through. While mainstream science does not support this idea, it reflects our desire to find meaning in the unknown. Another angle worth considering is the role of energy. When galaxies collide, vast amounts of energy are released as gas clouds compress and ignite. On a universal scale, a collision could release energy beyond comprehension. The Big Bang itself may be thought of as a singular release of energy that set everything in motion. If another such event occurred, it might look to us like a second creation, a sudden burst reshaping everything, scattering matter, and igniting new stars in patterns we could not predict. This possibility raises an intriguing question. Could a collision of universes be the engine behind cycles of creation? Perhaps our universe is not the only one born from such an event, but one in a long lineage of universes that rise and fall through collisions. If so, then the cosmos is not static but dynamic, a living process in which universes themselves are like waves crashing against one another, endlessly reshaping the sea of existence. The implications extend to time itself. In our universe, time flows in one direction, from past to future. But in another universe, time might behave differently. If the two collided, how would those different arrows of time reconcile? Could time loop back on itself, creating cycles where events repeat endlessly? Could time fracture, branching into multiple streams that coexist simultaneously? If so, then a collision might shatter our linear sense of history, plunging us into a reality where past, present, and future blend together. This thought takes us into territory that feels almost mythological. Ancient stories often describe worlds colliding, heavens meeting, or cycles of destruction and rebirth. Perhaps these myths reflect a deep intuition that reality itself is not singular or permanent, but layered and cyclical. Modern physics, in its most speculative forms, circles back to similar themes, suggesting that the end of one universe could be the beginning of another. What makes this idea so powerful is not just the physics behind it, but the perspective it gives us on our own existence. If universes can collide, then our own lives are not isolated, not even contained by the universe we know. We are part of a larger story, one that spans not just galaxies and time, but potentially infinite layers of reality. That sense of connection to something vast, mysterious, and beyond our comprehension reminds us of the humility required when thinking about the cosmos. It also sparks wonder. Could there be universes colliding right now, beyond our reach? Could new realities be forming in the depths of dimensions we cannot yet perceive? Could our own universe, seemingly so stable, be drifting slowly toward another, destined for an encounter that will reshape everything? These questions remain unanswerable for now, but asking them stretches our imagination and perhaps brings us closer to understanding the true scale of existence. When we talk about the collision of universes, one of the most profound questions is how it would affect the very structure of space-time. In our universe, space and time form a single fabric, stretching and curving under the influence of mass and energy. Black holes bend this fabric so strongly that not even light can escape. Gravitational waves ripple through it when massive objects move and merge. This fabric is not static, it is alive, flexible, and dynamic. Now imagine another fabric, woven differently, colliding with ours. What would that mean for the shape of reality itself? One possibility is that the collision would create immense distortions. Think of two waves meeting on the surface of the ocean. Sometimes they cancel each other, flattening the water. Other times they reinforce one another, creating towering crests. In the same way, the ripples of one universe colliding with another might either dampen or amplify the curves of space-time. Entire galaxies might find themselves suddenly drawn together or thrust apart. Vast regions of the cosmos might warp into new geometries, folding reality into forms that defy our current mathematics. Some physicists have speculated that if universes can collide, then black holes could be gateways to understanding it. Black holes already push our understanding of space-time to its limits. They seem to connect regions of reality in ways we do not yet fully grasp. If another universe pressed against ours, black holes might act as points of contact, places where the fabric of one reality stitches into another. Could they be seams where universes brush against each other? If so, the collision might not just be global, it could be channeled through these singularities, reshaping them into bridges between worlds. If we follow this thought further, it leads us to the concept of wormholes. Wormholes are hypothetical tunnels through space-time, predicted by general relativity but never observed. If two universes collided, wormholes might appear spontaneously, threading one reality into another. To beings like us, this could mean sudden portals opening in the sky, windows into alien realities. What lies on the other side might be incomprehensible. Different physics, different landscapes, perhaps even other forms of life. While this sounds like science fiction, it's a natural consequence of asking what happens when fabrics of space-time interact. Now let's consider scale. Our human perspective is bound by what we can perceive. Lifetimes, centuries, millennia. But a collision of universes would likely unfold across unimaginable spans of time. From our view, it might be gradual, barely detectable, like the slow drift of stars. Or it might happen in sudden bursts, like earthquakes shaking the ground after centuries of tension. The universe could remain stable for billions of years, only to lurch dramatically when the collision reached a critical threshold. If such a collision altered the flow of time, the experience would be even stranger. Perhaps some regions would slow down while others accelerated. Imagine standing in a place where time runs differently from your surroundings. You might see the stars whirl across the sky in moments, while your own heartbeat remains steady. Or the opposite, you might feel frozen while the cosmos around you stretches out endlessly. A collision between universes could make time itself unstable, breaking the steady rhythm that underpins our experience of reality. This instability raises the question of perception. Could living beings endure such changes, or would our consciousness dissolve in the process? Our brains are finely tuned to process information in linear time, to perceive cause and effect. If time fractured or looped, we might no longer understand the sequence of events. Memory could become unreliable. The distinction between dream and waking might vanish. In such a reality, the very concept of identity could blur, as our sense of self is tied so deeply to continuity in time. Another possible consequence of a universe collision is the appearance of new forces or dimensions. In our universe, 4 fundamental forces govern everything: gravity, electromagnetism, and the strong and weak nuclear forces. These forces create all the structures we see, from atoms to galaxies. But what if another universe with different forces collided with ours? We might suddenly experience entirely new interactions. Matter could behave in ways beyond our comprehension, perhaps even opening possibilities like levitation, instantaneous communication, or forms of energy far beyond anything we currently harness. Imagine a force that binds not matter, but information. In such a universe, knowledge itself might have weight, pulling realities together or apart. Or imagine a dimension that does not follow spatial rules, but logical ones, where cause and effect can be rearranged. While speculative, these ideas remind us that our universe's rules are not guaranteed to be universal. They are one possibility among many, and a collision might reveal alternatives. The idea becomes even more unsettling when we think about scale beyond our universe. If our universe is one of many, then collisions might be common in the grander multiverse. They might be happening constantly, unseen from our vantage point. Perhaps the reason our universe appears fine-tuned for life is because only certain collisions create conditions where stability is possible. Others might collapse instantly, leaving no observers behind. From this view, our existence could be the product of a rare and delicate balance achieved through countless cosmic interactions. Philosophically, this brings us to the question of meaning. If universes can collide, merge, or vanish, what does permanence mean? We often think of the universe as eternal, the backdrop against which all else unfolds. But if even universes are transient, then permanence may not exist at all. Reality may be fundamentally dynamic, a process without finality. That can feel unsettling, but it can also feel liberating. It suggests that existence is not fixed, but endlessly creative, always giving rise to new forms. Let's not overlook the possibility of consciousness persisting through such events. If consciousness is tied not strictly to matter, but to the structure of reality itself, then it might adapt to new conditions. In a collision of universes, awareness might transform rather than end. Perhaps we would perceive both realities at once, like overlapping layers of experience. Or perhaps consciousness could shift into new modes, freed from the constraints of our current physics. In this sense, a collision could expand awareness beyond anything we can imagine. From a practical standpoint, though, detecting a universe collision is nearly impossible with our current technology. We search the cosmic background radiation for patterns, we measure gravitational waves, and we model the dynamics of inflation. But direct evidence of another universe remains elusive. Still, the pursuit itself pushes science forward. Even if we never prove that universes collide, exploring the possibility sharpens our understanding of what is possible within our own. The beauty of this idea lies in its blend of rigor and wonder. Physics gives us tools, equations, models, predictions. Imagination lets us stretch beyond those tools into realms where equations have not yet reached. A collision of universes may never happen in our lifetime, or it may already be part of our past. Either way, the thought experiment expands the boundaries of what we can conceive, and in doing so, it reminds us that reality is larger, stranger, and more mysterious than our everyday experience suggests. For centuries, humans have asked where everything came from. The dominant scientific explanation is the Big Bang, a singular moment nearly 14 billion years ago when the universe expanded from an incredibly hot, dense state into the vast cosmos we see today. But the Big Bang itself raises questions. Why did it happen? What caused the initial expansion? And was it truly the beginning, or merely a transition from something else? Some cosmologists suggest that our universe may not have been born from nothing, but from the interaction of other universes. In certain models of string theory, our cosmos exists on a membrane, or brane, floating in a higher dimensional space. If another brane drifted near ours and collided with it, the result would be a release of colossal energy, igniting the Big Bang. In this view, our universe is not an isolated miracle, but the product of a larger cycle, one collision among many in a grander multiverse. If that's true, then the very reason we are here might be because universes collide. This redefines creation itself. Instead of a single, unrepeatable event, creation becomes a recurring process, like waves crashing endlessly against each other on a cosmic shore. Each collision may spark a new universe, with its own laws, its own galaxies, its own potential for life. Our universe is simply one wave in an endless ocean. This raises a profound implication. Collisions may not just be destructive, they may be generative. We often imagine a collision as something violent, but in the language of the cosmos, violence and creation are often intertwined. Stars are born in the chaos of collapsing gas clouds. Planets form from the debris of countless collisions. Life itself emerges from a delicate balance of destruction and renewal. On every scale, we know, creation is a process that often requires upheaval. Why should universes be any different? To make this idea more tangible, imagine a vast forest. Every so often, a fire sweeps through, destroying trees and reshaping the landscape. Yet from the ashes, new growth emerges, nourished by the change. In the same way, a universe collision might feel catastrophic in the moment, but in the longer view, it could be the spark that allows new realities to flourish. The destruction of one order could be the birth of another. What's equally intriguing is how such a process could explain the fine-tuned nature of our universe. Physicists often marvel at how perfectly balanced our cosmic constants are. If gravity were slightly stronger, stars would burn too quickly. If it were weaker, stars might never ignite. If the electromagnetic force were altered, chemistry might not exist in a stable form. The odds of everything aligning so perfectly seem astronomically small. Yet if countless universes are born from collisions, then it's not surprising that some of them stumble upon the right conditions for life. We are here, in this universe, precisely because it happens to be one of the rare survivors of cosmic collisions that allows consciousness to emerge. This shifts our perspective. Instead of seeing the universe as uniquely special, we might see it as one of many, its life-friendly qualities arising not from chance alone, but from a vast process of trial and error across countless collisions. Just as evolution on Earth experiments with life through mutation and selection, the multiverse may experiment with universes through collisions and rebirths. Those universes that cannot support complexity fade quickly, while those that can persist and thrive. Yet this also leads to a sobering thought. If our universe was born from a collision, Could another one end it? The same process that gave rise to us might one day sweep us away. A collision might be in our distant future, waiting silently beyond the horizon of dimensions we cannot perceive. For now, we enjoy stability, but perhaps we exist in a cosmic lull between collisions, a calm between storms. If we imagine such a storm arriving, what would it look like from within? Would the sky blaze with strange lights? Would stars shift suddenly in their patterns? Would the very fabric of space crackle with energies beyond comprehension? Or would it happen quietly, almost imperceptibly, until the new order had already taken hold? The truth may depend on the details of the collision, the degree of alignment between laws, the speed of impact, the depth of interaction. In some scenarios, we might not survive long enough to observe. In others, we might witness wonders that redefine our understanding of existence. Another profound aspect to consider is whether universes might carry memory of their collisions, just as geological layers on Earth record past events. Volcanoes, impacts, extinctions. Perhaps our universe holds scars from encounters long ago. Some scientists study the cosmic microwave background for evidence of such scars. Patterns that don't fit the smoothness predicted by standard models could be fingerprints of collisions. Circular anomalies, cold spots, or strange asymmetries might hint that our universe has brushed against others in its distant past. If so, then we are living in a cosmos with a history richer than we ever imagined, one shaped not only by its own expansion, but by interactions with neighbours unseen. There's another dimension to this idea. What if consciousness itself is a kind of record? If universes can influence one another, perhaps through quantum entanglement or deeper connections, then maybe our awareness sometimes brushes against those other realities. Dreams, intuitions, or inexplicable insights might be glimpses of overlapping universes. While speculative, it resonates with the human sense that reality sometimes feels larger than what we see. A collision could magnify this effect, making awareness stretch across multiple realities at once. On a more speculative note, some thinkers have asked whether life could survive such an event by moving between universes. If wormholes or dimensional bridges form during a collision, advanced civilizations might learn to navigate them. The collision could be a danger, but also an opportunity, a chance to escape one reality and enter another. Perhaps life in some distant universe has already done this, traveling the multiverse like explorers crossing oceans. If so, collisions would not only shape universes, but also the destinies of beings within them. The thought that our entire universe might one day merge into another challenges our sense of permanence, yet it also connects us to something larger. We are not isolated beings in an isolated cosmos. We are participants in an unfolding process far beyond our comprehension. If universes collide, then we are part of that dance, however brief or enduring our role. What happens to the laws of physics when two different sets of rules try to coexist? Right now, our universe is governed by constants and forces that seem stable. Gravity pulls with a certain strength. Light moves at a fixed speed. Quantum particles follow probabilities that have been measured with great precision. These constants give rise to everything we know, from the way stars burn to the way our DNA holds together. But if another universe with different laws collided with ours, it would be like mixing two games with completely different rule books. What happens when rules conflict? One possibility is that the laws of the stronger universe would dominate. If the other universe carried more energy, more mass, or simply had more influence in its interaction, its rules might overwrite ours. Suddenly, atoms could lose their stability, stars might change their lifespans, and matter itself could dissolve into forms that make no sense to us. From our perspective, it might appear as if reality itself was disintegrating, not because it vanished, but because the laws that made our existence possible were being replaced by new ones. Another possibility is compromise. Imagine two musical instruments playing together. At first, they may clash, each trying to impose its own melody. But over time, they might find a harmony, creating a new song that neither could produce alone. If universes collide, perhaps their laws could blend into something stable, a hybrid physics that merges constants and forces from both sides. This would mean a universe transformed but not destroyed, an altered reality where new forms of matter and energy could arise, unfamiliar yet consistent in their own way. Of course, there is also the chaotic outcome, a reality where the rules never stabilize, where constants shift unpredictably, and where no lasting structures can form. This kind of unstable merger might be short-lived, a flicker of existence that quickly dissolves back into nothingness. It would be a universe that could not host galaxies, planets, or life, a failed experiment in the grand multiverse. When we explore these ideas, we are also exploring the nature of what makes a universe possible. Ours appears fine-tuned not just for life, but for stability itself. Without predictable laws, there could be no stars, no chemistry, no time as we experience it. A collision forces us to imagine the fragility of this balance. We take for granted that gravity will be the same tomorrow as it is today, that particles will behave according to known patterns, that light will continue to move at the speed we measure. But if universes can collide, then even these bedrock assumptions may not be eternal. This raises a deeper question. Are the laws of physics truly fundamental, or are they the local rules of our specific universe? If universes can differ in their laws, then physics is not a universal truth, but a regional dialect of a larger reality. Just as languages vary across Earth, perhaps physics varies across the multiverse. A collision, then, is not just a physical event, but a meeting of dialects, a conversation between realities that could produce either harmony or chaos. Some theorists speculate that our universe might already be the result of such blending. Certain aspects of physics, like the strange imbalance between matter and antimatter, or the mysteries of dark energy, could be relics of past collisions. We cannot prove this yet, but it offers a tantalizing way to explain phenomena that standard models struggle with. Perhaps what we call mysteries are simply the fingerprints of other universes lingering within our own. For a more imaginative perspective, consider how such a collision might appear to observers living through it. Perhaps the first signs would be subtle, tiny shifts in the behavior of particles, anomalies in astronomical measurements, unusual energies appearing in the cosmos. Then larger changes would follow. Stars might flicker strangely, the night sky might ripple with unknown colours, and familiar laws of physics could start to bend. A glass of water might not freeze or boil at the expected temperature anymore. Gravity might pull slightly harder or softer, altering how we walk, how planets orbit, how time itself flows. These gradual but undeniable changes would feel like reality slipping out from under us. But there is also the possibility of wondrous outcomes. If new laws allowed for stable but unfamiliar forms of matter, we might witness phenomena beyond imagination. Crystals that grow into structures larger than planets, light that bends into spirals across the sky, or even forms of energy that could fuel technologies we can't yet conceive. A collision might not only endanger us, it might expand our horizons, giving rise to possibilities we never dreamed of. Philosophically, such scenarios challenge our sense of certainty. We like to believe that the universe is a fixed stage, reliable and permanent, where the drama of existence unfolds. But a collision suggests that the stage itself is mutable, that reality can be rewritten in ways that transcend our comprehension. It asks us to reconsider what permanence means in a cosmos where even the laws of nature are subject to change. Some thinkers have drawn parallels between this cosmic instability and human experience. Just as universes may collide and reshape themselves, so too do we collide with events, ideas, and people that transform us. Our identities, like physical laws, are not as fixed as we sometimes believe. We adapt, merge, and sometimes fracture in the presence of change. The collision of universes becomes a metaphor for transformation itself, frightening, unpredictable, but also fertile with new possibilities. If universes can merge, another question arises. Could beings survive the transition? Would consciousness adapt to new laws of physics, or would it be extinguished with the old rules that supported it? If survival were possible, it might mean that awareness itself is more fundamental than matter, that consciousness can ride the shifting waves of reality, adjusting to whatever form existence takes. This idea resonates with ancient philosophical traditions that see mind or awareness as the bedrock of reality, rather than physical matter. In a collision, matter might crumble, but perhaps consciousness could endure, reborn in the new reality that emerges. From a more scientific angle, survival would depend on whether the new laws supported complexity. If stable structures could form, atoms, molecules, stars, then life might re-emerge, even if in a radically different form. Perhaps what we call life is simply the patterning of energy into self-organizing systems. A collision could erase our current biology, but allow new forms to blossom, forms that we might not recognize, but that would carry forward the spark of self-organization. This also leads to an almost mythic image, the rebirth of existence through collision. In myths across cultures, the world is often created through conflict, gods clashing, chaos giving way to order, destruction seeding creation. The scientific vision of universe collisions mirrors these myths, suggesting that reality itself is cyclical, that endings and beginnings are not separate but intertwined. Perhaps one day, billions or trillions of years from now, our universe will meet another. The outcome is uncertain: annihilation, merger, or transformation. But whatever happens, the process will be part of the ongoing story of existence, a reminder that nothing is fixed forever. Not stars, not galaxies, not even the laws of physics themselves. Time is one of the most mysterious aspects of our universe. We experience it as a constant forward movement, but physics tells us that time is deeply linked to the structure of space. Together, they form spacetime, a fabric that bends under the influence of mass and energy. If two universes with different spacetime structures collided, then time as we know it might no longer behave in familiar ways. In our universe, time appears to have a direction. The past is behind us, the future ahead. This so-called arrow of time is tied to entropy, the tendency for systems to move from order to disorder. Yet if another universe had a different thermodynamic arrow, perhaps one where entropy flows in the opposite direction, the collision could create regions where time seems to move backward relative to our experience. To us, this might appear as a strange reversal of cause and effect, where outcomes occur before their triggers, or where events loop in baffling patterns. Another possibility is that time could fracture, branching into multiple streams. If universes with incompatible time structures merged, the resulting reality might not settle into a single arrow of time. Instead, different regions could follow different timelines. One area of the cosmos might experience rapid acceleration of time, while another might be frozen in near stasis. For beings within it, this would create a fractured experience of reality. Civilizations might look into the night sky and see parts of the universe racing ahead or lagging far behind, as if the cosmos itself was divided by temporal borders. Even more radically, a collision could erase time altogether, at least in the way we understand it. If the mathematical framework that supports cause, effect, and sequence collapsed, existence might take on a form that is timeless. Consciousness might no longer perceive events unfolding one after another, but instead experience everything at once. Past, present, and future would blur into a single eternal moment. For us, this idea is nearly impossible to imagine because our awareness depends so heavily on time. But in a post-collision reality, timelessness could be the new normal. If time were altered by a cosmic collision, the effects would ripple into every aspect of life. Our bodies, for instance, rely on sequences, cells dividing, chemical reactions ticking forward, memories stacking upon one another. If time fractured or reversed, the continuity of identity might dissolve. We might not be able to remember in the way we do now, because memory requires a steady arrow of time. Or we might find ourselves recalling events that have not yet occurred, blurring the line between prediction and recollection. Interestingly, some philosophers and physicists suggest that traces of such phenomena already exist in our universe. Quantum mechanics, with its strange probabilities and entanglements, sometimes seems to defy classical causality. In certain experiments, particles behave as if they are influenced by events that have not yet happened, hinting that time may not be as linear as we think. If universes have ever collided in the past, perhaps some of these anomalies are lingering echoes of a deeper, non-linear time structure left behind. For a more imaginative lens, picture standing on a planet during a universe collision where time flows differently in the sky than on the ground. You might look upward and see stars forming and dying in rapid bursts, entire cosmic life cycles unfolding in what feels like minutes. Yet when you turn to your own world, time might crawl, days stretching into what feels like centuries. The experience would be bewildering, but also awe-inspiring. A front-row seat to the relativity of existence when universes merge. Such scenarios inevitably raise questions about free will. If time is fractured or reversed, what does it mean to make a choice? In a timeless universe where all outcomes exist simultaneously, perhaps free will is redefined as awareness of multiple paths rather than movement along a single one. In a world where time loops, choices might be endlessly repeated, giving the eerie sense that destiny and freedom are woven together in strange and paradoxical ways. It also challenges our understanding of endings. We often think of death as the final boundary, tied to the linear flow of time. But if a collision reshaped time, death itself might lose its meaning. Consciousness could persist in timeless awareness, or cycle endlessly in loops, or spread across branching timelines. What feels like an absolute boundary in our universe might be just one form of transition in the broader multiverse. From a scientific perspective, studying time anomalies could be one way to detect collisions. Astronomers already measure cosmic events with extreme precision, looking for irregularities in the timing of pulsars or shifts in the expansion rate of the universe. If a collision with another universe left behind temporal distortions, these might be detectable as subtle irregularities in the flow of cosmic events. Perhaps buried in our data are signals of a past encounter with another reality. But the philosophical weight of this possibility is just as important. If collisions can rewrite time, then nothing we know is truly secure. Not even the steady rhythm by which we measure our lives. Our calendars, our histories, our very sense of progress could all be provisional, dependent on the current stability of our universe's time flow. A collision would remind us that the universe is not built for our comfort or predictability, but for transformation and renewal. There is also something oddly comforting in this thought. If time can be reshaped, then perhaps nothing is ever truly lost. The past may not vanish, the future may not be unreachable, and existence itself may not be bound by linear decay. In a colliding cosmos, everything could still exist, simply rearranged into a form beyond our current perception. What seems like an end might only be a new perspective on eternity. Another dimension of universe collisions to consider is the question of identity. Not just cosmic identity, but personal identity. If two universes with different histories or versions of reality were to merge, what would happen to the versions of you that exist within them? This idea forces us to look at collisions not only in terms of physics, but also in terms of individuality, consciousness, and the continuity of the self. In theories of parallel universes, there could be countless versions of each person. In one reality, you might be sitting exactly where you are now. In another, you might have made a different decision years ago that altered your entire life path. In yet another, you might not exist at all. If universes collide and merge, these versions might converge, overlap, or even blend together. But what would that mean for the sense of being you? One possibility is that multiple versions of a person would collapse into a single new identity. Imagine if every choice you never made, every possibility you never lived, suddenly rushed back into you. Your mind might swell with memories of countless different lives, some familiar, some alien, all overlapping within a single consciousness. It would be overwhelming, perhaps unbearable, to contain so many perspectives. But it could also be enlightening, giving you a panoramic sense of self that stretches far beyond one lifetime. Another possibility is fragmentation. Instead of merging smoothly, identities from different universes might exist side by side within the same reality, like overlapping shadows that do not fully align. You might catch glimpses of yourself living differently, feel emotions that are not entirely yours, or even struggle to know which version of you is the true one. In such a world, individuality could dissolve, replaced by a spectrum of overlapping selves that never quite settle into unity. Yet there's a third possibility: multiplicity. If a collision did not force identities to collapse or fragment, it might allow all versions of self to exist simultaneously, accessible in ways they were not before. Consciousness could shift between them, experiencing different paths, different choices, and different outcomes, as if flipping through chapters in a cosmic book. In this scenario, you would not be limited to a single life. You would live all possible lives, moving fluidly among them as the universe restructured itself. This speculation raises profound questions about memory and awareness. Our current sense of self depends heavily on memory, the thread that ties past experiences together. But if universes collided, memory might no longer be linear. You could remember events from multiple timelines, some of which never happened in this world. Dreams, déjà vu, and sudden flashes of recognition might become the norm rather than the exception, as consciousness struggled to integrate overlapping realities. Philosophers have long debated whether identity is a fixed core or a fluid process. A collision would put this to the test. If your sense of self can stretch, merge, or multiply across universes, then perhaps identity is less about permanence and more about adaptability. The essence of being you might not lie in clinging to one path, but in the capacity to evolve when reality itself shifts beneath your feet. This idea connects with ancient traditions that view the self as multifaceted. In some philosophies, the individual is not a single, unchanging entity. but a collection of roles, layers, or even reincarnations. A universe collision could turn this metaphor into reality, making visible the multiplicity that may already exist within us. Instead of being shocked by the merging of selves, we might learn to embrace it as a natural expansion of awareness. On a more speculative scientific level, one could imagine that brain function itself would be affected by such a shift. If multiple versions of you merged, the brain might suddenly operate at higher levels of complexity, processing vast amounts of information from many lifetimes. This could lead to bursts of creativity, profound insights, or even the ability to perceive reality in fundamentally new ways. But it could also be destabilizing, overwhelming the fragile equilibrium that consciousness relies on. Another perspective is to imagine what this means for society. If universes collide and people merge with alternate versions of themselves, civilizations might suddenly acquire knowledge, technologies, or histories from countless other timelines. Entire cultures could be transformed overnight as new possibilities flood in. Imagine waking up in a world where humanity remembers both its successes and its failures from parallel realities, holding the wisdom of countless paths. This could either unite people in unprecedented ways or create conflicts over which version of history should prevail. It also raises an unsettling question. What if your alternate selves are not like you at all? Some versions might have lived darker lives, made choices you would find troubling, or developed personalities far different from your own. Would merging with them corrupt your sense of self or expand it? Could you reconcile with the parts of yourself that feel alien, or would they create inner conflict? A collision would not only test our understanding of physics, but also our capacity for self-acceptance. For a more visual angle, imagine walking down a street during such a collision. At first, everything seems normal, but then you start noticing double images, shadows of people overlapping, faint voices of alternate versions whispering alongside the ones you know. You might see yourself across the street, living a different life, only for that image to merge with you as the collision intensifies. The city itself might reflect multiple versions, buildings overlapping in impossible ways, signs shifting between languages, histories layering upon one another. Reality would become a living collage of parallel identities and worlds. Yet, as disorienting as this might be, it could also feel strangely unifying. Instead of being limited to one narrow version of existence, we might come to see ourselves as expansive beings, interconnected across countless dimensions. The collision would not destroy identity, but reveal its hidden depths. The you that you think of now might be only the tip of an iceberg, a fraction of what consciousness truly encompasses. There's another, more hopeful angle. If universes collide and multiple versions of self emerge, then perhaps some of our deepest desires, to know what might have been, to explore the roads not taken, would finally be fulfilled. You could experience lives you once only dreamed of, not as fantasy, but as reality. The collision would be terrifying, but it would also be a gift, a chance to see the vast range of what it means to be you. Beyond physics, beyond identity, beyond time itself, a collision forces us to rethink what existence actually is. In our day-to-day lives, reality feels solid. We trust the ground beneath our feet, the air we breathe, and the stars above our heads. But if a collision with another universe can rewrite the rules, then perhaps what we call real is only temporary, a local arrangement of deeper forces. The solidity we cling to may be less like a permanent structure and more like a ripple on an ocean, stable for a time but destined to change. One perspective is that a collision would expose reality as layered. Imagine peeling back a curtain and discovering another stage behind it, and another behind that. Each universe could be a layer in a grand structure, all connected yet distinct. A collision would be a moment when the layers touch, revealing the broader architecture of existence. For us, it would feel like a revelation. Reality is not one stage, but many, stacked and intertwined. Another perspective is that a collision would show reality to be fluid. Instead of a fixed stage, existence might be more like a river, always flowing and reshaping itself. Universes are not eternal objects, but temporary eddies in this current. When two eddies meet, they swirl together, changing form, merging or dissipating. From this angle, a collision is not an exception, but a natural process in a cosmos defined by movement and transformation. But perhaps the most daring perspective is that reality itself is not out there at all, but in some sense, emergent from consciousness. If universes collide and merge, and yet awareness persists, if the sense of self adapts to new laws, new timelines, new identities, then maybe consciousness is the deeper constant. Matter, time, and even physical laws may change, but the fact of awareness remains. A collision, then, would not erase reality, but simply reveal a new way for consciousness to experience itself. This possibility resonates with some interpretations of quantum mechanics. At the smallest scales, reality seems less like a fixed stage and more like a set of probabilities, resolved only when observed. Some physicists argue that observation itself plays a role in shaping outcomes. If this is true, then universes colliding might not just alter physics, they might alter how awareness interacts with the cosmos. Consciousness could be the bridge that survives the collision, a thread weaving through every version of reality. On a more scientific level, a collision could also give us clues about the multiverse itself. Right now, the multiverse is a hypothesis, a way to explain puzzling phenomena, but not something we can observe directly. If universes collided, the evidence might finally become undeniable. We could see imprints in the cosmic background radiation, witness shifts in fundamental constants, or detect strange energies that cannot be explained by our own physics alone. A collision could transform the multiverse from speculation into reality. For civilizations advanced enough to study it, a collision might be both a challenge and an opportunity. On one hand, it could threaten existence as they know it. On the other, it could offer new realms to explore. If universes overlap, perhaps pathways open, bridges between worlds that were once isolated. Imagine entire civilizations stepping across the threshold into a new universe, bringing with them knowledge and culture, encountering others who have done the same. The collision becomes not an end, but a meeting point, a cosmic crossroads. This idea also has profound implications for meaning. If universes can merge, then permanence may not be the measure of significance. We often seek meaning in things that last. Monuments, legacies, stars burning for billions of years. But in a colliding cosmos, nothing may last forever. Meaning would have to be found in the moment, in the act of being, in the awareness that shines even as realities shift. The beauty of existence would lie not in its permanence, but in its constant unfolding. To picture this, imagine watching two universes collide not as a disaster, but as a cosmic symphony. Galaxies ripple and merge like waves of light. Laws of physics intertwine like instruments playing together. Consciousness expands, experiencing new dimensions of reality. It is not destruction, it is transformation, the cosmos creating new forms of itself. From this perspective, a collision is not something to fear, but something to marvel at, a glimpse of the infinite creativity of existence. At the same time, we must acknowledge the limits of imagination. Our minds evolved within one universe, under one set of rules. To fully grasp what a collision would be like may be beyond us. Yet in trying, we stretch our understanding, and in that stretching, we touch something profound. The idea of universes colliding is less about predicting the future, and more about expanding our vision of reality itself. This is the true gift of thinking about such possibilities. It reminds us that the universe is not small, not simple, not fixed. It is vast, layered, mysterious, and alive with potential. Whether or not universes ever collide in ways we can witness, the very act of considering it reshapes how we see our own existence. It makes us humble, but also deeply connected to the wonder of being alive in a cosmos filled with possibility. We have imagined the physics, the time shifts, the merging of identities, and the rewriting of laws. We have considered destruction, transformation, and creation, all woven together in the fabric of possibility. And through it all, one truth shines clearly. Reality is far larger and more mysterious than we can ever fully grasp. If such a collision were ever to occur, we might not survive it in the way we understand survival. Our universe might dissolve into something unrecognizable. But the deeper lesson is that nothing is ever truly lost. Collisions, whether cosmic or personal, are moments of transformation. They break apart what was, but in doing so, they create space for what can be. The universe itself is a testament to this. Stars die so that new stars may form. Galaxies merge and blossom into grander spirals. Life on Earth has risen through countless cycles of destruction and renewal. Why should the story of universes be any different? In many ways, the idea of colliding realities is not just a thought experiment about the cosmos, but also a metaphor for our own existence. Each of us lives in a world shaped by countless collisions, moments where paths cross, where choices shift the course of our lives, where endings bring beginnings. Just as universes can overlap and transform, so too can we grow from the encounters and changes that define our lives. It is easy to fear what lies beyond our understanding. The thought of universes merging can feel overwhelming, even terrifying, yet it can also remind us of the wonder of being here, now, in this fragile and extraordinary moment of stability. Out of infinite possibilities, we exist in a universe where stars shine, where life thrives, where consciousness can look up at the night sky and wonder. That is already miraculous. Perhaps one day, far in the future, our universe will meet another. Perhaps it already has, leaving faint echoes in the patterns of cosmic radiation. Or perhaps it never will, and the multiverse will remain forever hidden from our sight. In the end, what matters is not whether we witness such a collision, but that we are able to imagine it. The act of wondering expands our awareness, carrying us beyond the limits of what we see into the infinite possibilities of what might be. And now, as you let these thoughts drift through your mind, it is time to let go. Let the vastness of the cosmos cradle you. Let the mystery of infinite universes be a gentle reminder that you are part of something boundless and beautiful. Whatever realities may collide, whatever transformations may come, in this moment you are safe, you are present, and you are free to rest. Close your eyes, breathe deeply, and allow the wonder of existence to guide you into a calm and peaceful sleep.